there are lots of different ways to factor. I already showed you a video on some simple factoring, which is factoring a GCF from a polynomial. That was this video, so go back and look for that if you need to. Okay. Generally, that's when you see a binomial and you're factoring it, but not always. You could use this method for factoring a trinomial as well. But today we're going to move on to the opposite of, let's see if I can find my other paper, the opposite of multiplying binomials. So when we multiplied binomials, we ended up with a trinomial. Multiplied binomials, ended up with a trinomial. You don't always, but most of the time you do. Today we're going to take a trinomial and factor it and end up with our two binomials. Remember, I talked to you about the fact that the distributive property is multiplication and factoring is actually division. So we're going backwards now. We're going from this step backwards up to our two binomials. And the first one that we are going to factor is x squared plus 11x plus 24. Okay. Now, in order for us to figure out what the two binomials are, we have to actually have the breakdown of what this middle term, remember we would always combine the two middle terms to get our middle term. So we have to get that breakdown. And polynomials should always be in standard form, which is ax squared plus bx plus c, where a, b, and c are just numbers. Okay. In this instance, a is 1, b is 11, and c is 24. A method that we use to solve these, to work backwards, is we know that a times c will give us factors, and those factors have to add up to 11. So what we do is we take a times c, and we say that's 24. And now we need the factors of 24. So we start off, okay, 1 times 24, 2 times 12, 3 times 8, 4 times 6, and there are no more. So what I'm actually looking for is the two factors that are going to add up to b, which is 11, right? b, 11. And they're right here, 3 and 8. So what I do now is instead of keeping this as an 11x, I'm going to make it a 3x plus an 8x. I have not changed what this polynomial is worth. I've just broken that 11x into two different terms. Okay? Factoring is now taking these four terms, split it in half, okay, invisible, not really doing this, and then doing the factoring that I've already shown you with this binomial and this binomial. So I take aside one side here and I say, what's the GCF between these two terms? And the GCF here is an x, and if I were to divide it out, I'd be left with x plus 3 in my parentheses. Okay, double check it by distribution. Now I take the other half of my polynomial and I do the same thing, and I ask myself, what is the GCF between these two terms? And it happens to be a positive 8. If I were to divide out that positive 8, I'd be left with an x plus 3. Notice that these two binomials are the same. That's what you have to have in order to factor. So now what we can do is we can say that this was a distribution of two binomials in the first place. And the first binomial was x plus 8, and the second binomial is x plus 3. And it looks exactly the opposite as the video that we did on multiplying binomials. Okay, and the great thing about factoring and multiplying is you can always go backwards and forwards to check your work. If you now break this apart into a distribution and do your multiplication, you should come up with the original polynomial.